An important step in showing the distributive law is true for cross product is this strange little lemma that involves only dot products. It'd be nice if we could actually show the cross product's distributive law was true in a more straightforward manner, but we're sort of stuck. Meanwhile, this is something that actually gets assigned very often in a linear algebra class. And like I said in the notes, if you're a STEM major, and absolutely if you're a math major, you should try to prove this first. So what we're going to do is just say if u dot d equals v dot d for every d. Now what I'm going to do is just subtract v dot d from both sides and then undistribute. Then, let's see here, bring it over and then distribute. What we're going to get is u minus v dot d is always equal to 0. And again, for every d. Now that says I should be able to put any d I want to in there, and that's going to work. Let's choose one specific d. And I want to pick u minus v, like that. Then u minus v dot u minus v equals 0. Remember that any vector dot itself is the length of the vector squared. So that's going to say that u minus v length squared equals 0. But if the length squared is 0, we certainly could take the square root. Let's do this. So what we're going to get is that the length of u minus v has to be 0. Well, there's only one vector who has length 0, and that's a 0 vector. So that's going to tell us that u minus v must be the 0 vector, because the 0 vector is the only vector of length 0, and then we can add v back to both sides, and then we get our conclusion. Then u must be equal to v. And it certainly looks like we canceled the d. At no point did we divide by d, right? We chose very carefully one specific d, and that just that one d was actually enough to show us that u actually had to be equal to v. Now, just a conclusion, if u dot d is always equal to v dot d for every d, then you can cancel the d's. And again, in a linear algebra class, it's often part of the homework that says, show that you can find, a d so that u dot d equals v dot d, even though u isn't equal to v. That's actually one of the activities I want you to try. And certainly if a math major, you should try to prove this. And if you're a math major, hopefully you were able to do that one too.